So I apologize for if you watched the biology video, the audio's quite low. I had the wrong microphone setting. I was using the microphone that's on the laptop, not the headset. So my apologies for that. I hope this is sounding a little bit better. So now we're going to do the review for the the chemistry unit. So a couple things. Again, we'll do the same thing. I'm going to eliminate a number of things that you don't really have to worry about. You should kind of know them because they're from the grade 9 course. So it's helpful to know, but you don't really need to know it. So don't focus on it for this. First thing, though, I've got to review quickly is the Boar-Rutherford diagram. You will not have to draw a Boar-Rutherford diagram, but it's important to know this because it's based on this Boar-Rutherford diagram that a lot of the other information that you need to know is sort of hinges on that. So what we need to look at, I'm just going to do an example. We had started this already. The thing that I want you to remember is this. Remember this word ape. The atomic number, this is what you get from, you read this from the periodic table. Okay. That's information that you're going to get from the periodic table. I'm going to switch over to the periodic table. I hope you're using this one on the exam. I don't know which one Mr. Pandolfi gave you, but the main thing is you're going to look at the key in the periodic table. So I'm going to switch over to the Nelson periodic table. I'm going to scroll back up to the first page of the periodic table. And so the main thing is when you're looking at the periodic table, you want to review this key. The key tells you where the information can be found in the different cells. So as you go and find the information, a couple of things that you're going to be paying particular attention to is you've got the atomic number here. I don't know if I can grab this. No, I can't really select it. But the atomic number. So the atomic number comes up. It's usually in the top left corner of of each cell for the periodic table. Of course, the periodic table is organized by atomic number code. So it's atomic number 1. On the other page, would it be atomic number 2, 3, 4, 5, 6, 7, 8, 9, 10? Then we start at 11, 12, 13, 14 on the other page because this is a 2-page periodic table. I'm just looking at the 1 page right now. So the atomic number, you've got the symbol. You've got the name of the element, and there's a couple of other things like these. It says this common ion charge and the other ion charge. We're going to pay particular attention to that as we go through some of these chemical formulas. So this is what we're working with right now. So I'm going to go back to our chemistry review. So looking at the periodic table, if you look at magnesium, maybe I do have to go back to the periodic table. So magnesium is atomic number 12. So if that comes out in the video, I'm moving the cursor around the atomic number. It's atomic number 12. So if I go back to that, the word ape here. So we get the atomic number from the periodic table. That tells us directly the number of protons. So the atomic number is the same as the number of protons in the atom. And if it's a neutral atom, it'll also tell us the number of electrons because protons are those positively charged particles, electrons are the negatively charged particles. And if I have the same number of protons and electrons, then altogether my positives balance out my negatives and I end up with a zero charge, a net charge as seen from the outside. So let's look at magnesium. So we found that it had atomic number 12, so I know it's got 12 protons, and I don't worry about the neutrons because we don't really worry about that for chemical reactions. That plays a part for other things, but not so much in the chemical reactions. So if I have 12 protons, I also have to have 12 electrons. But if you remember this Boar-Rutherford diagram, only 2 electrons can fit in the first energy level, and then 8 electrons will fit in the second energy level. So that's a total of 10 there, but I need 12. So The third energy level could hold 8, a maximum of 8, but I only have 2, so it's going to look like this. So I've got 2 electrons, 8 electrons, and then 2 electrons. Now this, I'm going to circle it in red. This is the key for chemical reactions. These outer electrons that we call the valence electrons. Okay, the valence electrons. These are electrons that will be given, they'll be taken, they'll be shared, and depending on the reactions that are involved in the compounds that use these electrons. But it's these electrons that become key in binding these elements into compounds. So we needed to know that. This next question here, you can ignore this, is just practice looking at. So for what it's worth, boron, this is the atomic number 5. So that means it has 5 protons. So the electron configuration for this would be that I'd have boron, I'd have 2 electrons in the first energy level, 3 electrons in the valence shell, and again the valence electrons are what we're after. You don't need to know this. You won't have. I shouldn't have anything like that on the exam. Okay. Here we get into the heart of it. We're going to write some chemical. We'll have some chemical formulas here. We're going to get the chemical names from that, and then we'll go do the reverse. We'll have the chemical name, and we'll see if we can come up with a chemical formula, and we'll work on some tricks to make that a little bit easier to work out. Okay, so first we have to look at. We got to remember, of course, when it comes to chemical symbols are always either a capital letter or a capital letter followed by a lowercase letter. So if I see 2 capital letters back to back, I know that they're 2 different elements. If I see a capital letter followed by a lowercase, those 2 go together. So in this case here, I've got K and Br. And if I go to the periodic table, I find K. Well, K is potassium. I won't go back and forth too much because it'll waste too much time. So K is potassium. So potassium is the metal if it's on the left-hand side of the periodic table, and Br is bromine. Now the thing that you got to remember when we write these chemical names, we take the first one is the metal, and we just write out the metal name. So potassium. And we take the non-metal bromine, and we take the ending of bromine and change it to IDE, so it becomes bromide. Okay, some of them are simple, some of them are. Oh, let's look at phosphorus. This next one here. So this next one here, we look up Ca in the periodic table. That would be calcium. I'll leave that to you to do this with your own periodic table, if you have one handy. And the next element is phosphorus, but again we want to change the ending to IDE, and it's not so simple as bromide. We changed bromine to bromide. Phosphorus doesn't become phosphoride, it becomes phosphide. Okay, you'll have to try to remember some of these things. We've got Al and then Cl. Well, Al is aluminum, so again the metal we write first. We just write it as it is, what it is. It's aluminum. The next element, the non-metal, is chlorine, so we're going to change that to chloride. And you can probably imagine a couple of others. Okay, now we want to undo it. We've got the name. We want to figure out what the chemical formula is. Now this one it becomes a little bit trickier, and you'll see there's ways to deal with this that so you might be familiar with. The first one I'll show you is what we call the Crisscross Formula. So the first thing we want to do is we want to say, okay, how are we going to make this formula up? Well, first we have to get the element symbols. So we've got aluminum and oxide, which is oxygen. So the symbol for aluminum, again, is Al. Oxygen is O. But now we have to start to look at these. This is where these valence electrons come in, are critical. So let's go back to the periodic table. And one of the things that I should have pointed out is this. When you look at the periodic table, we've got these group numbers. So this is group number 1, group number 2. Let me go back down to the next page. So we go over, if we go across the other side, we've got group 13, 14, 15, 16, 17, and 18. And what's with the exception of the first row, hydrogen and helium, where there's only one electron for hydrogen because there's one proton, and 2 electrons for helium because there's 2 protons. With the exception of that, when we want to find out how important these electrons are going to be, and these valence electrons, and what they're going to do, we have to look at this group number. This group number actually tells us the number of electrons that are in the outer shell, the number of these valence electrons. And what you want to focus on is the last digit in the group number. So group number 13, the last digit's 3. That number 3 tells me that boron has 3 electrons in the outer shell. That's the example I just did. So it's got 5 protons, 5 electrons. 2 electrons go in the first energy level. There's 3 left to go in the next energy level, and that's the outside one because it's not full. Aluminum, if we look at it, it has 13 protons, 13 electrons. So there's 2 electrons in the first energy level, 8 electrons in the next energy level, and then finally 3 electrons in the outer energy level. And so this number of this group number here, the last digit in the group number, will tell me how many valence electrons there are. Okay, let me go back to our note, because there's one thing that I omitted when we first started. Let me go back up to that first page. Okay, these valence electrons we can get, so we look at the group number to figure out the group number, or the valence electrons. We look at the group number and we take the last digit. If I have a group number is 1 or 2, well, it only has 1 digit, so the last digit is the only digit that it has. The last digit tells me the number of valence electrons. But then these valence electrons have to obey what we call the rule of 8, or the Octet Rule, depending on who's describing it. The Octet Rule. And what this means when we talk about this Octet Rule, for reasons that you don't need to know for this course, if you may learn it if you explore chemistry a little bit further later on, is that these electrons, in terms of valence electrons, this outer energy level will either, when it combines, it'll either completely fill up to be 8. So it'll either I'll either add electrons. We add electrons to make 8 valence electrons, or in the outer shell. And pardon my shorthand for electrons, the E minus electron, because a negative charge on the electrons. We either add electrons to make 8 electrons, or we take away electrons, away to make 0 valence electrons, or in that outer shell. Okay, so think of it as all or nothing. It's all or nothing. I either add something to fill it up so it can be 8. 8 is our all, or we take away electrons to make it 0. But the thing is, you do what's easiest. It's just as easy to add electrons as it is to take them away. I'm going to have to leave it here because I'm running up to 15 minutes. I'll save this video, but hang on, there'll be part 2 in a couple of minutes.